right, so can we just pretend like it's not there? Hi, ladies, you're missing class today, so we're going to record the notes. Get out some loose leaf and copy the notes as if you were here in class, and do the homework, which you're going to pick up from me, I'm sure. Okay. We are going to do what I call an advanced simplified. That just makes it sound hard. It's not really hard. You just have to be really, really careful. It's only things we've already learned, but you have to be really careful, okay? So here's the first one. This one doesn't even have any x's in it. 2 times 3 times 5. Not even any x's. This is an advanced. But it sets the stage for how to do these problems, right? If I asked you to multiply this and I said no calculator, I don't want to know the answer. I know you're doing it in your head. How would you do it? What's the first thing you would do?
2 times 3.
You would say 2 times 3. Some people draw arrows or underline, but you pay no attention to the 5 at all, and you just do the first 2. And then what do you do with that 5? You bring it down, okay? And then you take care of these 2 next. Agreed? Do you have to start with 2 times 3?
Yeah. No.
You know, not if you're multiplying, you don't. Okay, if you're subtracting or dividing, but if you're multiplying, you can start with 3 times 5 if you like. What's 3 times 5?
15.
15. And you can just bring that 2 down. And 2 times 15 is 30. You're going to get the same answer either way. In fact, if you wanted to be a real rebel, stay crazy. Cassidy, you know, always rebellious. You can put the 2 and the 5 together first. It's all multiplied. What's 2 times 5? Yes, I get you crazy. It's 10. And what's the one I haven't used?
30.
And what's 10 times 3?
30.
So the point is, you can rearrange it if all you have is multiplying to an order that you like best. Okay? And none of those are better than the other. This is not new. This is something you've learned before. Okay? All right. So now let's do one that has x's in it. We've done this before also. No matter what order you multiply these things in. I'm going to start with these 2x times 5x. 10x squared. Okay. And then 10x squared times 4x is 40x cubed. And this is the last one that I'm probably going to work 2 different ways. But I just kind of want to make sure you see that if you decide to do it in a different order, you can still get the same answer. I'm not going to do it for every single problem. We could start at the back of this. That's 5x times 4x. 20x squared. And then 2x times 20x squared is 40x. So either way, okay? All right, we're still not to the advanced part yet. So let's keep up on it anyway. Do you have any questions? You have 6 people that are here. Any questions? All right. So what about this? I still have 3 things multiplied together. But this time, I have a monomial, 1 term, a monomial, 1 term, and a binomial. Okay? You can multiply these together in any order that you want, but don't try to do it all at one time or you'll get messed up. So start with the first 2, and you come at you. Just start at the beginning. What is 2x times 3x? 6x squared. And then bring down the x plus 5. And what property are we going to use now? Okay. And we get 6x squared, 6x cubed plus 30x squared. So it's not really complicated. You just have to take a little bit of extra time to make sure you do things in a good order. There's nothing magic about that order. If you wanted to, you could have started, I'm not going to do this, but you could have started with this, what I underlined here. If we did that, what property would we have to use first? Distributive. And then we would say 2x, and we'd have to do distributive a second time. So it's a little faster to start at the beginning of this problem. All right, let's try another one.
That plus one.
It is plus one, it's like an H. Okay, you good? All right, so unless there's some reason to do it in another order, might as well start from the front end, okay? We're gonna do these two, yeah. What property is that?
Distributed.
Distributed, okay? That gives us 3x squared minus 12x, okay? That's the first part, everybody good? Now what?
You double distributed.
Okay, bring down this, and, let me hang on to that answer for just a second. Somebody tell me what's wrong with what I have written here. I have to take all of this, all of this, for people who aren't here, and multiply times this. All of it. So how do I say on paper, this works, to take all of this and multiply it? What do I need to put in? Parentheses. This step right there is the step that people forget the most often. Okay? All right, and now, what am I going to use to do that now, Bethany? Double distributed, also known as FOIL, sometimes by the box method. This particular one now has a square in it. We haven't seen one like this before, but we can handle it. I'm going to do FOIL. If anybody wants to set up box or double distributed, that's fine. When I say 3x squared times 2x, what do you get? 6x, I got an x squared times an x, 6x cubed, yes? And I'm gonna draw that moon shape, 3x squared times 1 is 3x squared. Now I'm gonna go underneath here and do negative 12 times 2. Negative 24, it's an x and an x, so x squared. And then negative 12x times 1 is minus 12x. So we just kind of got an extra x going on, okay? I don't think that's hard, it's just a little more complex, a few more steps to do. Usually right here, I have some people who just jump in and try to add everything together. You remember, you can only add them together if the exponents match, okay? So if nothing matches this, we'll start with that one, it's the highest one. These two match, so I can put those together, and you don't probably need your calculator very much on this, but if you ever get to the point where you want to use your calculator, just pick it up. You need to say 24 minus 3, which is 21, this will be negative 21, and then minus 12x. Yes, Helen?
That's 6x is 63.
And don't do what I did. Make sure you write a 3 when you're thinking of 3. Okay, 6x cubed. Okay? Does that follow? Okay, you could have started this problem by doing this first. If you did that first, what would you have done at the beginning? Double distributive, and then you would have done regular distributive. It would have just been in a different order. Either one of them works fine, you should get the same answer. Okay, and now, is that number 3? Four. Okay, so the last one. I'm going to give you 400 examples, I'm going to give you 5, okay? None of these are monomials. All of them are binomials. This is not hard, but you need to take your time so you don't make any careless mistakes, okay? We can either start with the first two or the last two, it doesn't make any difference, so I'm just gonna go ahead and start with the first two. What am I gonna use for this? FOIL. If everybody please do FOIL, double distributed, box method, whatever works, and get that answer for you. I want you to get the first FOIL part. They have 2x squared minus 7x plus 3. Okay. I have to take all of that, so what does that mean when I say that? I take all of it. Put it in parentheses. and I have to multiply it times this piece over here, which is already in parentheses.
So it will be a plus.
So it'll be in parentheses. Now, I will say that this piece right here, this bit of multiplying out is not hard, but you have to be very careful. You can't say FOIL, or else you leave a piece out. Box method people, your box is just gonna be 3 by 2 instead of 2 by 2. And double distributed property instead of double, how many terms have I got here? It's triple distributed. So what you basically do is you take this one, 2x squared, and you multiply it times x. And that gives you 2x cubed. And then you take 2x squared and you multiply it times 2. Some people like to draw the arrows. I think the arrows start getting very messy when you get there than the binomials. Okay? So you do 2x squared times 2, which is 4x squared. So that, I'm done with this piece I'm done with. And now I'm gonna go over and I'm gonna work with the negative 7x. Okay? And I'm gonna say negative 7x times x. Negative 7x squared. Then I'm gonna say negative 7x times 2. And that's gonna give me negative 14x. And now I'm done with the 7x. So what's left to use? The 3. Now I'm gonna say 3 times x. 3x. And then I'm gonna say 3 times 2, which is 6. It's not hard, you just have to be nice and slow. Can y'all see what I mean by these arrows starting to get in the way when you have like these longer triple distributed property problems? They really kind of get in the way. Underlining or pointing, and really basically understanding what you're doing. You're doing the 2x squared times both of these. Then you're doing the negative 7x times both of these, and then you're doing the 3 times both of these. Okay? Now you need to go through and add your like terms. Remember, you want to start with the highest power first. Oh, this has come out a nice order, hasn't it? It doesn't always happen. So we get 2x cubed, these two, minus 3x squared, these two, minus 11x, and then that 6 hanging on through it. Is everybody good? Now we're going to do a little calculator activity that I want to make sure y'all all follow. Grab the calculators. You don't need to write anything down for this, but I need you to do it. I think we sometimes forget what it means when we are simplifying. Okay? What it means when we're simplifying. We're changing the way something works. Okay? Here's an expression. 2x minus 1, x minus 3, x plus 2. I want somebody to pick a nice x value for me, not super weird. Okay? 3? So okay with 3? Okay, so let's say x equals 3. When you type this in, right here into your calculator, but everywhere it says an x, I want you to put a 3. So it's going to say 2 times 3 minus 1. Oh, I don't want 3. I'm sorry, it's going to give us the number I don't like. Can we pick this 5, okay?
Yeah.
All right, I'm sorry.
Keep it in the parentheses?
Yep, so type it in so it looks just like this. You remember how at the beginning of the year we practiced typing messy stuff in our calculator? What we've done is we've just gone through it. Every place we have an x, we type that in. I have no idea what it is.
1,252.
What? I got 1.6. Right, let's wait until everybody gets down. 9 times 2 is 8.
So I did by myself.
Okay, so 126? Okay, now, take this problem right here and just use the same number, x equals 5. Put a 5 in for each of these places. So you're going to say 2 times 5 cubed minus 3 times 5 squared minus 11 times 5 plus 6. What do you get?
101.
You should get 126. Okay, try again, you should get 126. Helen, I bet you put some pluses and
No, I
minuses,
put
or you put some.
5 instead of 2, just the first number.
Okay. I think you should get the same number. That's what we're saying when we say that that first one and the second one equal each other. We mean that for any number that you plug into them, it will always be the same thing. It doesn't have to be a simple, easy number like 5. Either it can be a weird number, and it will still work for exactly the same thing. Did everybody get the 126 now?
Yes.
Okay, what we're gonna do is one more time, we're gonna pick a weirder number. And this is one we're gonna have to be a little more careful with our calculators, because it seems like maybe we need a little practice. Let's pick a weirder number. Do you want to do a decimal or a fraction? Decimal. Let's do negative decimal, okay? Let's do negative.
25.
Let's do one with a,
29.
let's put a number in front of it, just for the heck of it. 3.6. There you go. Negative 3. Okay. Be bold. Negative 3.65. So you're going to type this in right here, and everywhere you see an X, you're going to type in negative 3.65. Make sure you're not putting a minus. Make sure you're using the negative. And use a minus for the other ones. Yeah, I would do this one too.
Oh, I got a big number. Yeah, negative.
Yeah, wait. I don't think I can type it off properly. Woo, negative 91.
Yeah,
We have a whole bunch of stuff at the end of it. I said, you don't have to write this all down, I'll get it up here. Negative 91.07175. Yes? Okay, so what was the number I used?
Negative 3.65.
Okay, now, I'm making y'all do this because we have a little trouble sometimes typing negative numbers in with exponents. Does anybody remember what you have to do with negative numbers when you want to put an exponent on them? Just reminded you right there. What do you have to do with negative numbers when you want to put an exponent on them? Parentheses. Okay. And you should get that same answer.
Is that a negative or a minus?
Negative. Okay, if it's just in front of a number, it's a negative. It can't be a negative unless it's between figures. Okay? Then it has to be a minus.
Oh my gosh.
That's right. The same answer.
Negative 91.075.
175. Should be the same thing. Okay? Should be the same thing. So, I mean, it works for everything as long as you type correctly. And it's not so much a matter of this answer being better than this. They both are useful for different things. Okay, good. All right, that's it. After you copy this, these notes, ladies, you will have homework that I'm sure you've already picked up from me. If not, it should be posted on the top of this page. It is worksheet number 3.18.